its life together. Well, I thought so, and then it froze. It finally looks okay. Would you like the lights off, Grant? Okay, then you can turn them off. Okay, so I want to go over the bell ringer, even though you don't have it in your hands anymore, hopefully. The reason we're going to go over it is because if you can handle the bell ringer, you can handle what's to come. So the bell ringer talks about Ramon and his backpack. So he's rolling it along at the airport. His backpack is 3 3/4 feet tall. And he is pulling it 3 feet from the ground. And then they want to know about this angle. So what trig function do I need? Sine. So I'm going to say sine of x equals 3 over, and instead of 3 3/4, I'm going to do 3.75 because, like you, I'm a decimal person. How do I kill off sine? Okay, and so I'm going to do sine inverse of 3 over 3.75. When you did that, what did you get? Do you recall? What was it? Okay, so it said nearest degree, so we're going to say 50 degrees. Okay, unless you're Katie, because you were playing on your phone. Yes, you just got caught on my YouTube video. Unless you weren't paying attention. Whatever, I don't care. Unless you weren't paying attention, because they weren't. Is there anyone who was paying attention and doesn't understand how I did this? Okay, ask me.
Every time you do sine, you have to do the sine inverse?
If sine is next to x, I'm trying to get x by itself. Since sine's bothering x, I'm going to do sine inverse. It's because sine is bothering x. If sine wasn't next to x, I would not do sine inverse. Okay, if you had all those done, then you're ready for what's going to happen today. So the learning target looks a little scary because it says angle of elevation and depression, but really all it is word problems involving what we've been doing. Okay. Patience is not a virtue that I have. I have very little. I have to pray for it sometimes. Okay, so angle of elevation and depression. When you look out in the world, what you're seeing, that's called your line of sight. Angle of elevation implies which way are you looking? Are you looking up or down? Yeah, and Eric's doing it with his head. You're looking up. It's like me looking up at the projector. That's elevation. So what we're going to talk about is either calculating the degree I'm looking up at the projector, or we're going to calculate based off how high I am, how far is the projector off the ground, or how far away am I from the projector. That's the kind of thing we're going to figure out today. Okay, angle of depression is like if I was the projector, I was up in the air, and I was looking down at you. That's going to be angle of depression. Angle of elevation problems tend to be a little easier, so I'm always excited when I see those. Okay, elevation. Elevation tends to be easier. So angle of elevation is already set up for us. In fact, the first one is. The angle of elevation is always, obviously, at the bottom of the triangle because we're looking up in the air. So we're down here. It says that we're at point A. We're looking at the top of a hill. We need to figure out how high the hill is. We're 400 feet away. We're looking up at a 49-degree angle. So I'm going to put an X on this side. I have to decide which trig function do I need, sine, cosine, or tangent. I need tangent because I have the opposite and the adjacent. So I'm going to have tan 49 equals x over 400. So I'm going to type in my calculator 400 tan 49 so I can get x. Point what? Okay, and so in this section, I of course appreciate if I see that, but on all the problems, we're just going to end up rounding to the nearest because almost all of them ask for that anyway. So I'm going to say about 460 feet. Are there any questions about how I set that up? Okay, well, number one, it was a little easier than number two. because on number 2 is where we start drawing our own pictures. On the worksheet, it's about the one from today, all the pictures are drawn for you. On the one for tomorrow, you draw your own. But again, it's kind of obvious what goes where. For instance, you know the sun goes in the sky. So I've got my sun. There's a telephone pole. They tell me the telephone pole is 12.5 meters tall. And then they tell me that it casts an 18-meter long shadow, so I need to figure out where to put the 18. Does it go on the hypotenuse, or does it go on the bottom? Why does it go on the bottom? Okay, but more importantly, we have good common sense. Where do shadows happen? On the ground. So that's why the 18 goes on the ground, because it's the shadow. They ask us for the angle of elevation. Again, angle of elevation implies we're looking up at something, so no, not the top angle. Yes, this bottom angle. And now we have to pick which trig function, and I did not mean for it to be this way. Most of my problems today are this one. Tangent. So I'm going to have tan x equals 12.5 over 18. But this one is a little harder. Why is that? To get x by itself, because tangent's bothering x, I have to use tan inverse. So I'm going to type in my calculator, tan inverse 12.5 over 18. And now I need a degree. So I'm going to say about 35 degrees. So the angle of elevation is about 35 degrees. Is there anyone who's confused? Okay, so we've done, both of the problems we've done were elevation. Again, elevation tends to be a little easier than depression, but we're going to move on to depression now. If you flip to the back, it says we need to find the angle of depression. And they describe a ski run, which we definitely don't have around here. It has a vertical drop of 208 yards, and they want us to find the angle of depression. Let me back up a second. So I'm going to draw the exact same picture here. What surprises most people is that the angle of depression doesn't happen inside this triangle. It doesn't. It's actually here. I wish I hadn't written the 1,000. It's actually here. It's not the top angle in the triangle. It's actually outside the triangle. Now, saying all that, when we had two lines cut by a transversal, we had one on this side and one on that side. What was that called? They're alternate interior angles, and they're congruent. So the angle of depression and the angle of elevation, they match. So there's an extra step required, and that Katie has to think through, oh, since I put an X there, I get to put an X here. But really, it's not that much extra work. Okay, which trig function do you need for this problem? Sine, because we're given the offset and the hypotenuse. So I'm going to have sine of x equals 208 over 1,000. The sine is bothering my x, so in my calculator I need to type in sine inverse 208 over 1,000. So it's really, for real, about 12 degrees. But again, what we solved for was this number here. But by alternate interior angles, we know we also get to put that number there. what I'm afraid is going to happen and what my old self would have tried to do is to solve for this angle. You can't see that. To solve for the third angle in the triangle and get 78. But no one's asking you about that third angle, so this is not necessary. I mean, Sawyer can do it for kicks and giggles, but nothing in the question requires that. Okay, are there any questions about number 3? Okay, 4 is going to be just as nice, and 5 is the only real pain of the day. Okay, Maria's at the top of a cliff. So here's Maria with her long dangly hair on her cliff. And the cliff is 40 feet above the water. The angle of depression is 52 degrees. What is the horizontal distance from the cliff to the nearest foot? Okay, in all the problems, there's still going to be a triangle. So I know there's this triangle. I know the angle of depression does not go inside the triangle. In fact, it goes here. But by alternate interior angles, this angle is also 52 degrees. So now just to figure out where to put the x, do I put the x on the bottom of my triangle or do I put the x on the hypotenuse? Oh yes, and I've forgotten my seal.
Ms. Compton?
Yes, ma'am.
Would you please let Sawyer Callahan know we have something in the main office to pick up at your convenience or
Yes,
outside?
yes, ma'am. I drew a shark instead. I don't know how to draw a seal. Thanks. I love drawing. My shark and airplane look very similar, yes. You ought to look at my key for tomorrow's worksheet. My airplanes look just like that. Okay, but what am I wanting? Am I wanting the hypotenuse to the bottom of the triangle? Did you read? What did they say? What did they want? Where is horizontal? Okay, so I'm going to put an X on the bottom because they said horizontal and I can read. Okay, do I need sine, cosine, or tangent? I'm not given the hypotenuse, so I need tangent. Tangent 52 equals opposite over adjacent would be 40 over X. Yes, I multiply both sides by X. Yes, I solve, but by now you should realize my answer is going to be 40 divided by tan 52. If you need to, you can. But you're just slowing yourself down. When you type it in the calculator, what did you get for X? 0.2 what? Okay, so about 31 degrees. 31 degrees, 31 feet. Miss Compton. Read the problem. Read the problem. Okay, are there any questions about number 4? It looks real good. Let me tell you. So good. Let's go to number 5. Number 5 is the only challenging one of the day. And then we're going to discuss one on your worksheets. Let's see. At a diving competition, there's a 6-foot tall diver. A 6-foot tall diver stands atop the 32-foot platform. So let's put him on his diving board. He had to climb a ladder to get up there. It's 32 feet tall. 2 feet. The front edge of the platform projects 5 feet beyond the end of the pool. Well, that makes sense because diving boards hang over the pool. So the diving board is 5 feet long. The pool itself is 50 feet in length. So far I've gone through most of the sentences. A camera is set up at the opposite end of the pool. Even with the pool's edge. If the camera is angled up so that its line of sight extends to the top of the diver's head. Oh, I overshot. Here's my camera. Let me make a bigger camera. What is the camera's angle of elevation to the nearest degree? There's a lot going on in this picture. I drew a giant picture with a lot going on. Did I absolutely have to figure out this problem? No. Again, it all ends up being a right triangle issue. So I'm just going to simplify my picture over here and draw a smaller one with just numbers that I need. I know I'm solving for this angle. I know I'm solving for that angle of elevation. I need to know how far it is from the camera to my steps. Or it would be from my camera to my guy, and it would be 45. Okay, they got 45 for the bottom of this triangle because this guy to here is really only 45 feet. My pool is 50 feet long, but I'm standing over at 5 feet because I'm out on the diving board, so I'm really only 45 feet away from the camera. Okay, and then I need to know how tall it is, and I do 38 because I was 32 feet in the air, plus I'm 6 feet tall, so from the very ground to the top of my head, it's 38 feet. Now, if you realized all that without drawing the picture, you don't have to draw the picture. But to be honest with you, the first time I did this problem, I had to draw the picture to try to figure out where to put what. Okay, do I need sine, cosine, or tangent to solve that triangle? So I'm going to do tan x equals opposite over adjacent, so 38 over 45. I need to get rid of tangent, so I'm going to use tan inverse. I need to know tan inverse of 38 over 45. So I'm going to say about 40 degrees. $40 I'm looking for the angle. What is the camera's angle of elevation? Yes, it's an angle for once. Haha. Yay. I did one thing correctly today. Okay, are there any questions about this? Okay, Danny can pass these out. The ones Danny's passing out are what I'm going to call the easy ones that you could have done before you leave the room today. They're that easy. The stack. The stack Sabby's passing out. There's good news and bad news. The good news is they're just as easy. The bad news is you have to draw your own pictures. There is a hard one on the worksheet that Sabby is passing out. It's number 4. So again, Sabby's passing out the harder one. Number 4 is difficult. Tomorrow when Grant walks in, I'm going to have a similar number 4. I'm going to change the numbers and do it myself on the board. I need Mark to be smart enough to look at my picture. And if Mark is testing tomorrow, then he probably wants to take a picture of my picture so he can make sure he gets the problem right. When do I probably want all this stuff from Mark?
Tomorrow.
Well, when do I really? I would take it on Monday, but is Mark going to hand it to me on Monday? So when should Mark hand it to me? He should probably hand it to me tomorrow because he's not going to remember till like next Wednesday, and then it's over. I would take it on Tuesday, but he's already annoying me. So, can you give me this on Monday? I want both by Monday, Trey. Is that nice? Can you handle that? Let's put it this